All right, welcome to section 2.2 of Pre-Calculus 20. Today we are going to look at what happens to the value of sine, cosine, and tan as the terminal arm goes around the origin, so to speak. And we're going to be introduced to a new term which is called quadrantal angles, and you've probably not have heard that before. But otherwise, you're going to see a lot of familiarity with things you have done before. So let's take a look, first of all, at this cool Flash program that has been installed here on the notebook software. As we move this green arrow around, or this green terminal arm, pardon me, around, you'll see that the values of sine, cosine, and tan are changing. And as we go from being close to the x-axis, and you can see the value of sine is smaller than cosine, and tan is fairly small as well. As we get closer to the y-axis, you can see that sine is going up while cosine is going down, and tan is also getting larger. And as we get close and right at 1, we see that tan gets really big really fast. Look at that. It's 57. It was just at 28. It gets really fast. And then all of a sudden, boom, it's not there. It doesn't exist. It's not possible. And that is because of the divided by 0, which is right down here. We can't divide by 0. So what's going to keep on happening? Well, as we go around, now sine was at 1. Cosine is at 0. Cosine turns negative, and sine goes back down. And it's getting smaller and smaller and smaller. And it goes down to -1 is the value of cosine at this negative x-axis. And this would be what we could just talked about, a quadrantal angle. This is an angle that ends right on an axis. It's not in quadrant 2 like it is here. It's not in quadrant 1 here. This is a quadrantal angle right at 90 degrees, then at 180, then at 270, quadrantal. That is the definition. And you can see the values are always 1, 0, or -1. If we go down to here, you see again tan is undefined, but sine is -1 and cosine is 0. If we go to here, right on that axis here, just got to steady myself here. Why won't it let me be right on the money here? There we go. Sine is 0. Cosine is -1. And we're going to see some patterns here that whenever we're on the x-axis, cosine is 0, or pardon me, sine is 0 and cosine is 1 or -1, as you'll see there. And similarly on the vertical axis, y-axis, that the x value is always 0, which corresponds to the cosine, and the sine is 1, or if we go down here, sine is -1. And those values are determined by tan as well. And you'll notice there are some variables here, y, x, and r, that sine and cosine depend on. We sometimes use the abbreviation or the memory device Sir Coxer Hicks to help us remember the relationship between y and r and x. And if we just look at the next page here, all that is simply is a right triangle, where r is your hypotenuse of the right triangle for any point on the terminal arm, and y is the vertical distance, and x is the horizontal distance, and all we run into is Pythagoras' theorem with regards to that. Now what we're going to do today is we're going to be making a chart of exact values, and that's what we're going to do next. So I guess I should erase these values that are just kind of in the way. We're going to fill this in, and we're actually going to have some options and see what we remember from what we did at 90 degrees, etc. And so when we click on the box here, we have a choice. What do we want this value to be? And I would say at 90, if you look, it's always the y value. Sine of 90 is 1. And you can also check that on your calculator that the cos of 90 will be 0, which corresponds to the x value of the point at 90. And because tan is y over x, which you can kind of faintly see in the corner over here, right here, anything divided by 0 is not possible. We call that undefined. sorry, that's not true at 0. We're talking about at 0 degrees. Is that true? That if sine is y over r at 0 degrees, that is not going to be quite true, is it? Sine of is 0 at 0, and cosine is 1 at 0, and therefore 1 divided by, or 0 divided by 1 is 0. That's true. That's better. And then we find at 180, the values switch a little bit in that the cosine turns negative, but the other remain the same as it was at 0. And at 270, which is similar to 90, now sine is no longer 1, but it's negative 1. Cosine is still 0, and tan is still undefined. So how does that apply to a problem? It says check your answer by dragging in the terminal arm and checking to make sure. So let's just do that. Let's check and make sure that that's possible. So if we go to here, is that what we had at 90? Yeah. The values were 1 and 0, etc. Let's do a problem together here. A point is 15 units from the origin, and it has an x value of k, and it has a y value of 15, and an r of 12, and an r value of 15. That's how far it is from the origin. We always are going to have to start these questions by finding the values. So we know that r squared is x squared plus y squared for any right triangle, so we need to find the values. So 15 squared equals k squared plus 12 squared, so that's 225. Take away 144, because when you square those terms, you would get that. So 144, that's 56, 76, 81. So we're going to find when you square root that k will be 9, or the x value will be 9. The question is, what's the other restriction? Do we know if that's going to be plus 9 or minus 9? It says p lies on the terminal arm between 0 and 360, so anywhere along here it is. What are the possibilities for the answer? Well, if your y value is positive, it is 12. That means we have to be dealing with these two quadrants, because if we talk about the blue area, the y value would have to be a negative 12, and it's not. It's a positive 12. So we know our terminal arm, if I just draw a rough sketch, we don't know exactly where. It has to be here or there in order for it to be 12. So could it be 9 or negative 9? I think it could, because if we went this way, you could have the point 9 and 12, or if we went this way, it could be negative 9 and 12, and both could have a distance of from the origin of being 15, potentially, not drawn to scale. So we're supposed to figure out what's the value of the angles. Oh, what's the value of theta here? Or what's the value of theta there? And how are we going to find those? That's the challenge that you're going to see into your assignment. So I will just have to erase this work off to the side here, and then we can do that together. And I like to start with question B first, which is find the exact values. So the sine of the value theta could equal, if we talk about Sir Cox or Tix, the y value over the r value. Well, it could be 12 over 15, and for both cases that would be true, either thetas. Cosine of either theta, the value could be a 9 over 15, x over r, or negative 9 over 15. And then for tan, which is Tix, y over x, it could be 12 over 9, and we would put the negative to the top for the negative version, or negative 12 over 9, because the x value could be plus or minus. Now to find the value of theta, we're going to need to use our calculator. Now we would use any one of these to find that value. You could simply do 12 over 15 second function sine, and you would get the value. That would be the black theta, and then you'd have to remember that that would also correspond to the reference angle on this side, and you would use that to find the red angle. And so that's the basics of the lesson, and we'll do some more as you work, and you can ask me questions, and we'll work together to make sure that you understand the material. So good luck, and we'll talk about then.